Hi everybody, in this video we're going to pick up where we left off in the previous tutorial where we've created an CRUD application with sign in, sign out and everything. What we want to do now is implement a full user management functionality with sign in, sign out from the database with passwords and everything else, and we're going to demonstrate several important topics using Remult in a non-Remult routes, role-based access and UI control, lifecycle hooks, and excluding server-side code from the front end. And we'll do all of that with implementing our user management. And here are the requirements that were given to us by our users. So when we start, we have our Vite engine running over here. We have the Node.js server running on the second terminal. And in our source code, we have the index for Node.js, like we do in the tutorial. We have the auth.ts that is responsible for signing in and signing out. This implementation uses non-Remult routes for that. So it shows you that you can use Remult in your existing code. And here we have our user entity. Pretty straightforward. And our React code. And let's review the React code. Here we have a list of users. We get them from the database. This is how we add a new row to the grid. We give that row a new ID, so we'll know that it's a new row, and we need to have an ID because we want to have more than one at the same time. This is where we set the state. So when we set something, it actually saves the state. This is the code to save the user. If it's a new user, we insert, and if it's an existing user, we save. This is the code to delete a user. If it's a new user, if it's not a new user, we delete it from the database. Otherwise, we just remove it from the array. And some very basic TSX, table header, rows, name checkbox, save, delete. Pretty straightforward code. Great, so the first thing we want to do, and we're going to follow our to-do list over here, we want to be able to sign in based on our users from the DB. So we have here our auth.ts code. Okay, and we have here a static list of users, and we have the sign in method and sign out method. So let's go ahead first of all and add these two rows to our database. So I'm going to add Jane, who's an admin, and I'm going to add Steve, who is not an admin, and I'll refresh the table and see that it's saved in our database. Here we're using the JSON database, so we can see it here. We can see the table that was created with these two users. Perfect. Once we've done that, we need to go ahead and remove this list and use here the database tables that we have. So instead of getting this data over here, what we're going to do is repo user find first, where the name of the user is equal to the username from the request body. And this obviously needs to be awaited. And if we have, and this needs to be async. And if you found the user, we can say here const result user info, that's the structure of users that Remult expects. ID is user ID, name is user name, and roles is if user is admin, then admin, otherwise empty array. Perfect. And we'll use the result on the session, and we'll use the result as the response of this method. Great, so now that we have this, all seems nice and fun, but it will actually not work. Let's check out the terminal over here. Let's try to sign in. And we get an error here saying that Remult object was requested outside of a valid context. Try and run it with init API or Remult request cycle. And basically, when we say repo users, we are counting on an implicit Remult instance that is ready to use for us. And that Remult instance needs to work in the context of a specific request. For example, its user needs to be set, or the database needs to be the correct one based on our API. Now, when we are running it outside of Remult normal API route, then we don't have that information, and we just need to ask for it. So in order to ask for it, we're going to do over here API, okay, which will refer to our API as we've defined it before, and API from our API folder, and say with Remult async. And as soon as we do that, we also need to pass it a request as the first parameter, and our code will work for us, of course. Await. So what do we do here? We are calling with Remult, and we are giving it a request. When this will run, it will go over to our API, and run the get user, it will run the init request and everything else, set up remult correctly, and then provide it to us here to be available in this context. Now, if you're using Express, this is called with remult async. If you're using Fastify or anything else, this is just called with remult. And let's check out that it works. Let's go ahead here and try to sign in with a wrong value. We'll get invalid user info. And if we try to sign in with Jane, we can see that Jane is signed in. Perfect. Now, this is so commonly used that it makes sense to create a middleware for it to make it easier to use. So if you're using Express, instead of using this, you can add this to your route, API with remult, and then I can just take this away, and it will work. Or you can even add it as a middleware on an upper level, saying that all routes in Auth should have remult available for it. And that's very useful because you might want to use remult to get an image from the database or do anything else. Again, let's see that it works. Perfect. Great. So back to our README, we've implemented the first functionality. Next thing we want to do is add some restrictions to users. Basically restrict what they're supposed to do, but the most interesting one is to only show non-authenticated users. Non-authenticated. Yeah, let's start with that. So let's hover to our user TS and say here that only allow only authenticated users can see the data. Let's sign out, refresh. We cannot see the data. Let's sign in with Jane, and now we can see the data. So we've implemented that, which was pretty easy. The next one is more interesting. Non-admin users should only see themselves. So we want to be in a case where an administrator user can see all the users, but non-admin users, such as Steve, should only see their own row because maybe they want to update their name or phone, but we don't want them to be able to affect other users. So let me show you how we do that. We can head over to our user entity and say over here that it's a user decorator, and we're going to use the API pre-filter to say if remult is allowed admin, then return an empty filter. Otherwise, return a filter that says that the ID is remult user ID. What we're actually saying here is that if you are an admin, then we don't need to filter the data. And if you are not an admin, we will filter where the ID in the specific row is equal to the ID of the current user. Now, this API pre-filter will automatically be added to whatever filter that comes in over the CRUD API. Let's go ahead and check that. So I'm going to sign out and sign in as Steve. And we can see that Steve can only see himself. I'll sign out, sign in as Jane. And we can see that Jane can see everyone. Now, it's important to note that API pre-filter is added to all API requests on the entity level, but a backend method will not implement this filter, or non-remult routes will not implement this filter, and it's actually required because when we sign in, we don't have the current user and we need to search the entire user database. But if we want this to be also applied to any request, we can say over here a backend pre-filter, and then any request that is done to this entity will have this filter added for it. We can also have final control of things like update. We can say here that allow API update is only allowed if the user ID is equal remult user ID. Okay? And of course, it's an arrow function. Oh, sorry, I forgot the comma over here. And what am I missing here? Yes, of course it might come like that. So we can do specific operations based on specific users. The fact that it's arrow functions gives us a lot of functionality. Perfect. So we've done that, and let's just add a few more requirements. We're going to say that a user cannot delete on itself if it's not an admin, and also insert is restricted. API insert is requested for only admin users. Great. Let's head back to our feature list. Now, here's an interesting security bug. Steve, in theory, can check himself as an admin, sign out and sign in, and get the admin roles. We don't want that. We want to prevent Steve from updating his admin roles. So let's do that. we're going to head over to the admin field, and we're going to say that you can only update it if you're an admin, if you have the admin role. So now if I'll sign out and sign in as Steve, try to set the admin and save, it will not be saved. So that's how we can control individual field updates based on specific roles. Cool. Next on our list, we want to hide the things that Steve is not allowed to do. So he shouldn't see the create, and he shouldn't see the delete, and as far as I'm concerned, he shouldn't even see the admin, because we don't want him to be able to see those. But we want to use the same definitions that we have in our user TS. So let's go ahead and do that. So in our code, we'll highlight the create functionality and say that if our user repo metadata insert is allowed, only then show the create functionality. And for the delete functionality, we'll do something different or similar. User repo metadata, if delete is allowed, and we can actually send it a specific user because we can have rules that delete is allowed based on the specific row. So he will not see the delete. And we also don't want him to see the checkbox of admin. So we're going to say over here, user repo metadata, fields, admin, API update allowed, and that will hide the checkbox if it's not allowed, and we'll also add the same for the table header. So now Steve cannot see the admin. Now, the beauty of using the metadata fields admin or the metadata insert or delete is that we can base our UI on the same rules that apply to the API. So if at some point I'll remove this rule, he'll be able to see the admin, and if I'll add it back, he will not be able to see. If I'll remove the insert rule, he will see the create, and if I'll not, he will not. So I'm able to tie the front-end functionality to the same rules that I use for my API security, which I think is extremely powerful. Let's proceed to our next requirement. Let's support passwords. Okay, so we're going to support password. We're going to start with basic password and then build the functionality on and on. So let's head over to our user TS. We're going to add a password field. And we're going to add it in our UI. So let's add a header password. And let's add an input for password. Okay, we have that. And let's head over to our, let's set a password. Okay, so Steve has a password, and let's sign in as Jane and give Jane a password. And now let's go ahead and implement the sign-in process. Yeah, we need to set the default set value here. Let's head over to our OS TSX and set up, OS TSX. Let's add another input for password. Let's see how it looks. Password, password, perfect. And in our sign-in process, let's verify that we get the correct password. So we can say over here, if the request body password is equal to user.password, only then sign in. So let's check out this functionality. Let's go with Steve, put an invalid password, we're getting an error, put a valid password, and we're getting Steve. We can sign out and sign in as Jane, and we can see the data. So we've implemented the password functionality, and as we follow our requirements, the next one should be, we shouldn't see the password in the API. You should never include passwords in your API. So let me show you how we can hide that, but still maintain the ability to update the password. So the first thing I'm going to do is, I'm going to head over to our user TS, and I'm going to say that password is never included in the API. So now we'll not see it anymore. But we do want to allow the users some ability to update it. And to do that, I'm going to add a virtual field. It's going to call it update password. and I'm going to have it use an server expression to return 4 stars or 3 stars. Okay. Now this is not a real field, it does not exist in the database, it just returns these 3 stars. And let's head over to our front end. And yeah, give it a default value of blank, just like we do. And in our UI, instead of updating the password, we'll update the update password. So now we see these 3 stars over here. But we actually want the user to be able to update. So if we do here 456 save, we want this to be saved. And to do that, we'll use the lifecycle hooks. Okay, we have lifecycle hooks over on the entity level or even on the field level. So I'm going to say over here that when it's saving, okay, I want this to be of type user, so we know our entity. Then we have user, field ref, and entity lifecycle hooks. And I can say here, well, if the field ref value was changed, then user.password is equal to user.updated password. So when this will be saved, when the user entity will be saved, we'll check if the user password field was changed, and we'll update the user password based on the updated password. Let's check out this functionality, and to do that I'll also show the users file over here. So now if Jen does 456 save, it gets to be 456, but the API only exposes these 3 stars. So this is a great way to hide data from the front end but still allow it to get updated. Great. Next on our list is password should be hashed. Pretty important. We don't even want to store the password themselves, because if someone hacks my database, he may get someone else's bank password, and we don't want to do that. So we're going to use hashing algorithm from the package bcrypt. You can read all about it on npm. And we're going to use it over here. We're going to get a bug, and then we're going to fix the bug. But let's start by trying to do it. So the first thing I'm going to do over here, I'm going to import from bcrypt and use the hash function. And in our saving, when we save the password, we're going to say await a hash, and it gets the password, and I can give it number of iterations if I want. Now, as soon as I do that, everything may look fine, but if we check out the terminal, we can see that Vite has almost crashed. The problem that we have over here is that bcrypt is a function that can only run in Node.js. It cannot run in the browser. And the user entity code is shared between the front end and the back end. So it runs both, or at least compiles both, on the front end and on the Node.js backend. And we can't have that for bcrypt because it causes our code to crash. So there are several strategies of handling that, and we have an article on that using server-only code in the Remult documentation site. We're going to implement one of the methods which always works. Okay, it's a bit verbose, but it always works. What we want to do here actually is have a function that gets a string and returns a string. So let's abstract it and say here that we have a static hash. It gets a password with a string, and by default returns the same password. Okay, so we have a very simple abstract implementation of hash. Let's call it over here. Yeah, we want it to also be async because we want it to be a promise. So we're going to use it over here. User.hash, and we don't need the salt definition over here, and we can remove the import. So at this point, Vite is our friend again. So this is an abstract definition of a hashing method, and we're going to implement it using injection on our server. So we're going to go over here and we're going to say user.hash gets a password and then hashes that password from bcrypt using 10 level of sort. Okay, so what happens here is that by default the implementation is a naive implementation that looks like this, but when the server starts it replaces that implementation with one that uses the proper bcrypt hash. So on the server it will get the implementation and the front end it would not. Let's check it out. Let's look at our user JSON here and set a password for Jane, 123, save, and we can see that it saves a hash. And we're going to do the same for Steve, and we can see that it saves a hash. Look, even though the same password is set, these are completely different values, and it's one of the beautiful things about hashing. Now let's go ahead and adjust the server code to sign in with that hash. So we're gonna import from bcrypt the compare method, and we'll say over here if user exists and compare the passwords that we got in the form with the password that is stored for the user. And of course it's async, so we're gonna need to await it. Great, now let's go ahead and sign in. So I'm gonna go Jane 123, sign in, and we can sign in with the hashed password. And today that's the only way to use password. Never save the password themselves in your database. So after this 20-minute video, let's go ahead and review what we've done today. Gonna place it over here. So we showed how we can use remult in non-remult routes. We do that by using the with remult middleware or by using the API with remult async method that receives the request. It's important to know that it doesn't have to receive a request. If you want to run it from a cron job or from some kind of interval, whatever, you can simply send undefined here and it will work. And we've seen how we do role-based access for the UI and for the control. So let's head over to our user TS. We can see that we've said that CRUD is allowed only for authenticated, delete and insert is only for admin. Admin users can see all the data, but non-admin users can only see themselves. Password field should never be included in the API, and admin field should only be updated if you're admin. We also seen how Lifecycle Hooks can handle our operations as they happen. When we do saving over here, we store the password and we even hash it. And we've seen how we exclude server-side code from the front end by abstracting the call to an abstract call and populating it in our server code. I hope you liked this video. If you have any questions, do send them here either in the comments or preferably join us on our Discord channel and let me know what you think. Have fun!